Hi and welcome to our today demo, which is about Kubernetes networking. I'm sure you have all heard about Kubernetes, which is getting lots of attraction now these days. And many of the cloud providers like Google or Amazon or Azure, even they are providing the Kubernetes services to their customers. Kubernetes is a orchestration platform which can provide application deployment in a high availability manner using the containers and mainly specifically with Docker containers. So for example, you can tell to Kubernetes that go and deploy a WordPress for me on 5 instances and put the load balancer in the front. The Kubernetes master has this role for managing the Kubernetes worker nodes, and it can go and talk to the worker node, spin up the new containers inside the different worker nodes, and it will ensure that all of these containers, they are all operational. And it will also create a separate load balancer in front of all of these containers which are running, for example, this specific WordPress service. And also it has this ability to find out, oh, for deploying the WordPress, I need to also deploy MySQL as a base requirement for running the WordPress. You may think about why we are going to study the Kubernetes networking, or what is the specific about the Kubernetes networking here. The answer to that is the way Kubernetes works is Kubernetes requires that all the containers to be able to reach each other regardless of any layer 2 or layer 3 network in between them. And also the Kubernetes, the network provider, the networking system within the Kubernetes, it has this ability to create virtual networks, virtual overlay networks on top of the existing layer 2 or layer 3 network to be able to provide connectivity between the containers. Also, we need to remember Kubernetes is not like OpenStack, or it's not like VMware vSphere or any of these infrastructure management system. So in order to make the Kubernetes working, we have to create the Kubernetes worker node and the master node, and the master node does not build any of these worker nodes. So this is the duty of the system admin to create the worker nodes, or build the infrastructure for running the Kubernetes. Once the worker node is created, then it can be added to the Kubernetes master to be managed. And these containers which are being placed inside the Docker in each of these worker nodes, they will be placed by the Kubernetes master. Kubernetes master is not one single entity. So in highly available in production environments, you can create a highly available Kubernetes masters to ensure they provide high availability and business continuity to your production Kubernetes system. I think one of the reasons that Kubernetes mainly supports and uses Docker is because of the Docker Hub. Because whenever you need to create any kind of application, so finally it will get translated into a Docker pull command here in the worker node, which goes into the Docker Hub and download that specific container from the Docker Hub and builds and runs that container here. Similarly, also we have in Kubernetes we have something called Helm, which is like a package manager for Kubernetes. So Helm modules or Helm template, they are written more high level, and mainly you can create a Kubernetes Helm file to tell the Kubernetes to, for example, create these 5 instances and what type of the load balancer you have to put it in the front, or what kind of storage you are planning to use for this particular application. And this explanation of the Kubernetes which I provided here is just a very bare minimum. So Kubernetes also has lots of other features which it's out of the scope of our course. It goes into more advanced topics, but in general that's how Kubernetes works, and that's the main duty of the Kubernetes. All right. So for our demo, we will be deploying Kubernetes on on-prem servers to doing some demo about the Kubernetes networking. You can deploy Kubernetes using the very famous Kubernetes testing environments like Minikube, which can help you to bring up a whole Kubernetes environment with just a single virtual machine. And also there are some Kubernetes in the cloud testing labs available from Kubernetes and other partners of the Kubernetes, which you can use and do some basic tutorials for getting familiar with Kubernetes. Kubernetes has very good features when it comes to the public cloud providers. So, for example, with Azure, AWS, or Google Cloud, Kubernetes deployment implementation on those public clouds are working very well. When it comes to on-prem, some of the features are not available in like vanilla. For example, on the on-prem Kubernetes, there is no ready-made support for external load balancers for the Kubernetes. Whereas when you deploy the Kubernetes on AWS, and if you create a service using 5 different pods or instances, you can have just a load balancer in front of them, and the Azure or AWS can provide those IP addresses, the listener IP addresses, the external IP addresses to the Kubernetes. So in our demo, we will not be using load balancers. So we just create a Hello World deployment with 2 instances here in this demo. So we will have a Kubernetes master and 2 worker servers, and we will have the Hello World deployed on 2 instances, which they will be placed on 2 different servers. So once we do this deployment, you will be able to see that our networking provider for Kubernetes, which in this case today we will be using Flannel. Flannel will be creating a separate IPv4 network for each of these nodes. So the worker server 1 will have a different Flannel network. So all of our containers who are living in Kubernetes worker 1, they will have a different IP subnet than the containers which are all running on the Kubernetes worker number 2. And the Flannel networking here, it will be able to do the transfer of packets and networking between the Kubernetes networkers, between the Kubernetes worker servers. So Flannel is something very similar to Calico, and it does some stuff for doing VXLAN between the ports. So if the traffic, for example, is coming from container number 1 needs to go to container number 2, although there is no real routing here in our network to reach to the container network of the worker number 2, Flannel will be able to overlay that traffic to the Flannel server here on the Kubernetes worker number 2. All right, so now for starting the deployment, we will be using Juju. So if you go to the Kubernetes, there are multiple ways for deployment of the Kubernetes. I will be using this one, setting up Kubernetes with Juju, and because it's simple, and I'm also using this Metal as a service server, which is managing our server here in the lab. So all of our servers are managed by Mass, and Mass can provision these servers. These are all bare metal servers, and we will be using the Juju charm. Now for doing that, if I go to you can either start from here, follow the steps which are shown here. You can use this one, the Conjure Up, for setting up the Kubernetes, but I will not be using Conjure Up because I need to do some more customization. So I will just use the Juju deploy. Now to start with, I will go to the Juju Charms website, and from here I will go to, so Juju Charms is a platform, is a solution, as we described earlier, that it can deploy big softwares which have lots of components and stuff. We did the deployment of our OpenStack also using the Juju. Now if I go to store and I choose Kubernetes. For Kubernetes, they have different deployments. So they have a production cluster and this one, the staging cluster. We will be using this one because It just requires two machines, one master and one worker node. But I will do some modification here to make it for one master and two worker nodes. This one requires around 10 machines, which is much higher than what we are expecting as a demo. So this one is called Kubernetes core, and it will be deploying the Kubernetes master, etcd, easy-RSA, Finalo, and a worker server. Now etcd, this one is a distributed database for Kubernetes. So Kubernetes uses its etcd for storing information. So all the worker servers and also the master, they will be accessing this database. So for example, whenever you create a service or you create a deployment using Kubernetes, it will be written inside the etcd database. And Flannel is the networking. We can use also Calico, but in this demo, we will be using Flannel. Now, to start with, either we can use Conjura, which we will not be using that, and we will be downloading the file, the deployment file, which is located here. And I will be running this file inside our Juju console. So the Juju console, which is located here, I will do SSH to this box, and all of the deployment will happen from here, the deployment of the Kubernetes. So what I need to do is I need to download this file. So I will download this file directly on our Juju console. So let's connect to our Juju console. 192.168.2.5 that. Okay, so let's go to, we have a folder here, Kubernetes Juju deploy. It's empty. Let me download this file. So this is that bundle file which we downloaded. Let's have a view on what's going on here. So we have these machines. So machine 0, machine 1, and I want to add one more machine also here. And we will call that 2 because we want to deploy 2 worker servers. And one more thing about the constraint and these machines actually. Yeah, so these machines are all managed by mass. Let's have a look at the mass also. So this one is the mass, the 192.168.251.2, and if we look at our drawing, this is a server. It's a virtual machine, and this virtual machine is managing this deployment. Now within the mass, it just manages all of our servers. These are all bare metal servers. So we have few servers here. This one is running. So this one actually is running the Juju controller right now. And this is already managed by, it's already connected to the Juju. So these two servers, because they have more memory, I will be using these two servers as workers. For doing that, I have already assigned a tag to these servers. So this server 1, it has a tag of worker 128, and similarly we have the server 2 as well with the same tag, the worker 128. And I want to have this server 7, to become my Kubernetes controller. So I have a tag on K8-CTRL, the Kubernetes controller. So now to tell to Juju that I want to have the machine 0, which is going to be our Kubernetes master, we will say this should have a tag of Kubernetes controller, CTRL. And for the machine 1, I will add a tag of worker 128. And similarly for the other one also, we will say this one also tags is worker 128. The services, so easy RSA will be deployed 1 unit, and it will be deployed as a container, as LXD container on the machine 0. The etcd database, that will be deployed 1 unit on the machine 0, so it will be on the machine itself. Finalo will be deployed on all the machines, so it doesn't have very specific information. Kubernetes master, and we don't need these constraints here. Number of units is 1, and it will be deployed on machine 0. Kubernetes worker, we don't need this constraint because we have already said that earlier. And we need 2 machines for Kubernetes worker, and it will be deployed on 1 and also on machine number 2. And these are the relationship which the Juju will be deploying. So Kubernetes master connection to the Kubernetes API, etc connection to the database, and all of this stuff. So these are actually the automation script which Juju will run. So once it does the installation of the components of the Kubernetes, it does all of these dynamic configuration of this software component to connect them together. So technically it's changes of the view configuration file, putting the IP addresses or services names and connecting these applications together. And I will save this file now. So we have got this file, the bundle.yaml. So this is our Kubernetes file, which we will ask Juju to deploy this bundle. And once we start the deployment, we expect more servers to be running. Now to start with, we will just issue Juju deploy bundle.yaml. And by this command, it loads this bundle file and it starts talking to the Juju controller server. So Juju controller server, which is sitting here. So Juju console is transferring all of this information to the Juju controller, and Juju controller will start doing this deployment now for us. Now to monitor the deployment, so these are all the uploads which are happening, and let's give it some time. Okay, so Juju has completed uploading this information to the Juju controller. You can see we got bundle machine 0, bundle machine 1 and 2, they are called machine 3, 4 and 5 in Juju, and also added all of this relationship. Now we need to monitor that, what's happening there. If I issue the command Juju status, this will tell us that, what's happening. So here on the top, this is the model, the application. So we have EasyRSA and the other applications. They are sitting on the units, and units are sitting on the machines. So the 3 machines which we have here, this is the master. So it's got the IP address, and these 2 the worker servers, and this one also is a LXC container which is going to run the EasyRSA. So these servers are now in the deployment mode, and for the units they are saying that waiting for the machine to be ready. So what will happen here is that, let me put a watch here. If we go back to our mass server, in the mass here, now you can see server 1 and server 2, which are workers, deploying Ubuntu 11, deploying Ubuntu 18.04, and this one, which was supposed to be our Kubernetes master, is also having Ubuntu 18 installed. So we need to wait for some time for these servers to be up. After that, the Juju will start doing the deployment. So let's give it some time, and we will come back once it is completed. All right, so now as you can see, your deployment has been completed. Our machines are already deployed. This container is already started, and here we got some good information. So we have Finalo running on the master, and it has created a subnet 10.1.58.1. The other one on the first worker server is 10.1.9.1/24, and this one also is another /24 network. So 3 separate isolated network has been created for these 3 hosts, and these networks, they are not routable within our network. So our LAN here is just 192.168.251 0/24, and it has no clue about routing of these subnets, the subnet which has been created here. So these networks here only live inside the containers, inside the container engine of this host. They are all different. Okay, so now let's continue. So the deployment is being completed. Now we will continue on from here to complete our Kubernetes deployment. All right, so now we need to start interacting with our Kubernetes cluster. So for doing the interaction, I will use the same host, this host, to interact directly with our Kubernetes. To interact with Kubernetes, we need to download a configuration file from our master server, and we will use the kubectl client software, which is a Kubernetes client software, to connect to the cluster. So we need to get this file. So I will run this command. It's a juju command. I will run it on our here. So right here, actually, we don't have the configuration file. So with this command, we are telling juju to go and do a cp to the Kubernetes master and download the config file and save it here in the same folder. So when I run this command, okay, so that's not the master/0. We have to look at what is exactly it is called. It's called master/1. Okay. All right, so now we got the config file here. Let me do a cat of this config file. So this config file, it includes some information. It includes the certificate. Oh, it includes also the address for the server. So this is the master server, I think the API server of the Kubernetes, and also some more information about the admin password. So we need to get this file. I will put this file actually on the local machine here. All right, so let me copy this information and let me also create this file here. So this file should be copied into the .kube folder. .kube folder, it exists because I used to have the Kubernetes installed on this machine, and I will just create this file called config, and I paste exactly the same content here, and this file is saved now. Okay, so we have done this. So we got the configuration file. Now we need to install the kubectl software. So kubectl is the Kubernetes client software which we need to install. I will use it on this machine, so we don't need to do anything more with the juju. Everything will happen on the same machine, this machine which we are having. So let's install this software. We'll use the snap to install the Kubernetes client software. Okay, so let's copy this command and we use the snap. So I could use the sudo snap install, and this command we will download the Kubernetes, and okay, it just installed now. Now if I run kubectl cluster info, this command will load the configuration file, and from the configuration file it connects to the Kubernetes cluster. So here now it is telling us that, oh, Kubernetes master is running at this address. We have Hipster, we have kubedns, we have Grafana, InfluxDB, everything, you know, whatever is related to our cluster, it gives us this information. So this shows that our Kubernetes cluster is running, is healthy, and we can start using our cluster. All right, so now let's get access to our Kubernetes dashboard. So Kubernetes also includes a web GUI dashboard, which we can access it from here. So in our Juju guide, the README, so it tells us that how to enable the dashboard, which is the Kubernetes dashboard add-on. Add-on is installed by default. We just need to enable it, which normally it is enabled. So I run this juju command here on the juju host. Okay, so it says it's already enabled, so that's fine. Now to get access to the dashboard, we need to run the Kubernetes proxy. So Kubernetes proxy, when I run the Kubernetes proxy on this machine, it creates a tunnel back to the Kubernetes environment, because we don't have the IP addresses which are running our Kubernetes, they are not routable. So using the proxy, we will be able to access to our Kubernetes environment. Now from this machine, I will run kubectl proxy. So this command will start a proxy server on this machine, and it start listening on port number 8001. So whatever traffic we are sending to port number 8001, it will go to our tunnel to our Kubernetes environment. Okay, so now if I go to this address, so this address is HTTP localhost port number 8001, which is the proxy, API namespaces kube system. So we are going to call the Kubernetes dashboard, which is a Kubernetes dashboard service inside the kube system namespace. So Kubernetes has different namespaces. We can create namespaces. Kubernetes kube system is the namespace which is created for the Kubernetes internal system, like dashboard and the other stuff. So when we start using the Kubernetes, we can create different namespaces to create some kind of isolation, or by default we can also use the default namespace. Now if I load this address into our browser and hit enter, so it will tell us that okay, we need to do some authentication. So the best thing is either we can use the kubeconfig file, that config file which we have already saved, or we can create we can do a basic authentication. So I will use the kubeconfig, and let me see if I can access to .kube folder here. Yeah, so in home.kube and the config file, sign in. All right, so now we are signed into our Kubernetes dashboard. So in Kubernetes dashboard, as you can see, we have a cluster tab. The cluster tab shows us some information about the whole cluster, the status of the whole cluster, the CPU usage, memory. We have what namespaces do we have. We have a default and we have some other namespaces. The nodes are our worker servers. So we have two servers, server 1 and server 2. These are our worker servers, and it shows also the memory utilization and other stuff. If we go again here, nodes, it just shows us the same information. Persistent volumes are, as you remember during the demo of the containers, one of the major concept of the container is that the containers, they don't have any persistent storage by default. So whenever we launch a container, we have to attach a separate persistent volume to the containers. So for example, in that demo we had for the Docker with MySQL, we created a separate, we mounted a separate drive, we mounted a separate folder for the persistent storage for the MySQL. So it's very similar here in Kubernetes, because Kubernetes is also completely based on Docker. So we can create persistent volumes, and persistent volumes can be assigned for different applications when we are creating it inside the Kubernetes. And here we can choose the namespace, and it shows us the overview of that namespace. So inside our default namespace, technically we don't have much. We have only the Kubernetes service running here, and we don't have any pod running. So it means that we don't have actually any service running yet. So it's just the base installation of the Kubernetes is ready to start doing some deployment and running some applications. So now let's continue with our demo. So we managed to log into our Kubernetes dashboard. Now we are going to start launching a Hello World deployment with 2 instances and 2 servers, and we will access that services, that Hello World service from a browser. So the Hello World application is a Hello World basic deployment. It's like a Docker container, and we will be accessing that. All right. So now for creating the applications, let's start with Kubernetes documentation. So I'm in the Kubernetes documentation homepage, and let's go on the tasks, and Let's start with running application. No, let's do the access application in the cluster because we want to do some demo that how we will be accessing the applications. One of the things which I need to mention here is that when you create the application inside the Kubernetes, they will be all running inside those private IP addresses, which technically we don't have access. They are not routable from outside. So either your network should be able to route and reach to those IPs, or we have to use the techniques like the node port or the load balancer, the external load balancers, to be able to access to the internal services. So the one which we will be using, we will be accessing use a service to access an application in a cluster. Let's use this one. Yeah. So with this demo, which is mentioned here in the Kubernetes, we will be using this one. We will create a service for application running in two pods. So we will be using the kubectl to run hello world and replicas 2, so 2 nodes with this particular label. This is the image file, the image node hello from the Kubernetes. So this is the image repository of the Kubernetes, and this particular application will be listening on port number 8080. So let's run this now. And okay, I don't need this Juju anymore, so we have to keep the proxy enabled here running. Let me exit from here. So I'm back on the hosts and I will run this command now. So kubectl run hello world with replicas 2. And we can verify this by running kubectl, for example, get pods. So these 2 pods, the 2 replicas is being created here. So container creating. If we can keep refreshing this, we will be able to see the status of the container. Also, if we go on the web interface, if I refresh this one, so now you can see a deployment called hello world is created here and is being deployed, and we have 2 pods, the 2 hello world pods which are being created. One is running on server 1 and the other one is running on the server 2. The placement of these containers on the servers, this is all done by Kubernetes, so it has this much intelligence to distribute these particular containers on different servers. Replica set, it defines that we have 2 of these containers running for this service, and this is the service for our application. And in the services, we don't have still any hello world service because we have not created any service yet. So service, it becomes like a wrapper on top of this application to allow connectivity from outside to the service. So let's refresh this now and see if if they are created. Now they are still being created, and if I refresh the same here, still the containers are being created. So we have to wait for some time. And we can use these commands as well, get deployments, to see the status of the deployment. So, oh, now it is showing 2 of them are available. And if I do get pods, yeah, so it is showing that both the containers are running now. For more verification, we can use this command to describe the deployment. This is also another command which can help us to understand what exactly is going on. So the hello world application, where it is running, and more information about the load balancing or which port the application is listening on. Okay. The get replica set gives some information about the replicas. So same information which we had it in the web interface. Now, this application is running now. If let's have a look at the on the web interface. Okay, so now here it shows that the hello world both the pods are running, and but we don't have any way to access this application yet. So we need to create a service for our hello world to be able to see the hello world. Now, for doing that, we need to expose this deployment. So we will use this command to expose the deployment, the hello world deployment, using the node port, and we will create a service called example service. So example service will use the node port. Node port means the service will be using these host public interfaces. So the interface which we have on these hosts, we will be using these interfaces to connect to those servers. So let's do this now. We create this service, and let's create a service here. Okay, and we can use these commands to get information about the service itself. So it says the example service has been created. It's a node port. The IP address is 10.152. So this is the cluster IP, which is not accessible from outside yet. And it is targeted to port number 8080. Now, this one is the most important part because it tells us that the node port has been created. So our main nodes, they are listening on port number 30549 TCP. And if I try to access to one of our servers, the server IP address here, I will be able to see the hello world application. Now, what are the IP addresses of the host? That's something which I don't remember. We can, and that IPs are all dynamic. So the IPs which I have here, probably they are all changed now. Let's get an access to our Juju. From there, we can find out what are the IP addresses of our servers. Okay, and we run the Juju status. So our master is 192.162.51.145. We can update our drawing also as well. So this one is 145, the master. Our second one, the worker one is 146, and the second worker is 147. So this one is 147. And the Kubernetes worker number one is 146. Okay. And so now I know the IP addresses of our hosts. So what I will try to do is on the first one, the worker one, let me open a web page, try to access on port number. What was the port number? The port number 30549. Port number 30549, and here we go. So we got access to Hello Kubernetes. Now if I access to, so this one actually we are going directly to the Kubernetes worker number one, and Kubernetes worker number one is translating these. It's like IP tables running there probably, and this traffic is being routed to the container number one, which is running our hello world. If I access to the other one, to the 147 on the worker number two, the traffic will be routed to the container number two. Let's try that. We will say 147, and we get the same. So we are accessing server one and server two through this way. Now, if we have some kind of load balancer in the front, we could have access to the load balancer node, and load balancer node could send this traffic either to the container one or container two. But load balancers on the on-prem Kubernetes, it requires some more work because it doesn't have a standard implementation for the external load balancers. So there are some projects which are running, for example, the Metal LB. So that's one of the projects which is going on, I think, Metal LB. Metal LB is a load balancer implementation for bare metal Kubernetes clusters using standard routing protocols. And this implementation, so exactly this explains why Kubernetes does not offer implementation of network load balancers for bare metal clusters. So it does provide implementation of the networking load balancers for public clouds like Google Cloud or AWS or Azure, but it doesn't have anything for the local on-prem deployment. So this is one of the project which I think is very interesting, and you can use this to create a load balancer service for the on-prem implementations of the Kubernetes. Okay, so now we were able to access these two nodes, but let's have a look under the hood. Let's see what exactly going on here, how we are be able to access these, what is the flannel, what's going on inside these two nodes. So let's get two sessions to worker 1 and worker 2 and see what exactly is going on there. All right, so let's get another terminal, and let's make two connections to the Juju console. And two of them. Okay, so from here we can tell Juju I want to do SSH to this one, the first worker. Why I'm using this Juju commands is I might be able to do SSH directly here to this IP, but when you do this deployment with Juju, it loads the keys, the public and private keys directly from Juju to this host. So if I try to access this host directly, I don't think I will be able to do it. I can try that also. Let me do SSH directly here, and now it's permission denied. So I don't have that key. That's why I will use the directly from the Juju. So I will use Juju to SSH to the first worker, and the other one I will tell again Juju do the SSH to the server 3 here. Okay, so this one, now I'm sitting on the server 2, and this one is sitting on the server 1. Now what is going on? Let's make this screen a little bigger. First, let's have a look at what are the processes running. So we have Docker running here. We got Nginx inside this particular container. So these are all the container processes, Docker container processes running. And so if I do a Docker ps, let's do it with sudo, we see a lot of containers running on the server 1. Some of them are also, this one is the node hello, the hello world application which we created here, and the rest are all the internal Docker, the internal Kubernetes containers which are all running. So these containers are running the Kubernetes services, the Kubernetes internal application services, like kubedns and all the other stuff are all running here. And similarly on the server 2 as well, if I do a Docker ps, here we don't have much, but we have the hello world and also some controllers of the Kubernetes also running here. Let's see what are the IP addresses we have on this server. Okay. On the server 1, looks like we have many interfaces, and as you can see, okay, so this is the loopback ENP6F. This is the main network interface card, which is connecting this server, the physical server, to the network. So this one is running the 192.168.251.146. So this is the main IP of this host, the main connectivity of the host physically to the outside network. This is another physical interface which is down. We don't care about it. We have a Docker 0 network, but this one is down, so this is not used. And instead of that, we have a CNI network. So this is like a local bridge network instead of the Docker. So all of our containers, actually, instead of using a Docker 0 virtual switch, they are all connected to the CNI 0 virtual switch. And CNI 0 also is using 10.1.9.1/24. And we have a flannel.1 which is having some IP address also here. The rest are all virtual network interfaces. These are all the virtual interfaces for the containers, which are being connecting the containers to the CNI. Now, why CNI? We can have a look at our bridge CTL. So we have a Docker 0 and we have a CNI 0. So Docker 0, nothing is connected to the Docker 0, but on the CNI 0, we have all of these virtual interfaces of our containers are all connected to the CNI 0. So when we install in using Flannel, Flannel creates this CNI 0, and also it gets attached to the CNI 0. So whenever traffic needs to be going from one of the servers to another server, Flannel will be able to identify and route that traffic over using the Flannel and overlay that traffic using VXLAN to the other server. So this one, the server 1, as we can see, the IP address for our containers are all based on 10.1.9.0/24. To verify that, we can connect actually to one of our containers, to one of our Hello World containers. Let's do a connect to that, to one of our containers. So let's get the Hello World one. Let's get this one, for example, and it will say Docker exec IT. In this container, I want to get a bash. Sorry, /bin bash. Okay, so I think I have chosen a wrong container. Let's have a look quickly. Oh yeah, this container which we chose actually is a pause. We have to choose the first one, and so let me do this again. So this command, this is a Docker command which runs the /bin/bash. It gives us a bash shell on this particular container, which is the hello world. Here we go. So we are in the hello world container. If I do an IP address, you can see the IP address of this host is 10.1.9.11. So this is the container running at this IP address, and we are able to get that page through the proxy, through the node. So when we're calling the node IP on this port, we have a mechanism, IP tables mechanism, which is translating this port and sending this traffic to our server here. And if I do a PS, I think we should have, yeah, it's a Node.js server, so it's not Nginx, it's just running Node server here. And it's 10.1.9.11. Now let's go on the second server. Let's make this a little bit bigger. We do the same also on the server 2. So if I do a Docker PS, we have the hello nodes. Let me connect also here to the hello node. But by the way, we should have the same thing here. So let's have a look here. So we have the CNI 0, and CNI 0, it only has one interface because we have only the hello node running on this machine, and the Docker 0 doesn't have any information. And Docker 0 does not have any interfaces connected to it. And if we do an IP address, we have a different network here. So 10.1.68. So 10.1.68 is IP range for the host, for the worker number 2. Whereas on the worker number 1, the IPs are 10.1.9. So it's completely different. All right. So now on the server 2, let's do a route. Let's see what's the routing table. Okay, so let's do IP route. So we have 10.1.58.68, and we have a route also for 10.1.9.0. and this is routed over the Flannel 1 interface. So this means that if you, on the server 2, if anyone needs to talk to 10.1.9.0, which is the IP subnet of the server 1, it has to go through the Flannel. And Flannel will do the VXLAN encoding, and it will send this traffic to the server 1. Now let's connect to the container similarly. So we say docker exec dash interactive to this node, and I want to run /bin/bash, and this server is a hello world server, and its IP address is 10.1.68.2. Now from this server, if I ping to the other container, which is 10.1.9.11, 10.1.9.11, you can see we can ping that. And these two servers, 10.1.9.11, they have no connectivity between each other. So this traffic which we are sending from this host to his host, actually from this container to this container, it comes all the way to the bridge 0, and from bridge 0 it gets to the routing table of the Linux box, and it will get routed over the Flannel. So Flannel will knows that, oh, for reaching to the IP subnet of the worker 1, I have to send this traffic to the IP address of the server 1, and I have to encapsulate it using the VXLAN. Now, how these Flannels, they know each other? Because we never defined anything that, hey, this is the IP address of the range for the worker 1 and worker 2. How this routing is happening? The answer to that is all of this information is stored inside the etcd database. And these Flannels, they are talking to the etcd database, and they know which network each node is covering. Now let's go back here. Let's have a look at the server 1. We didn't check the routing table of the server 1. If I do IP route, so in server 1, we have a route for 10.1.9.0, which is this network, and we have also a route for 10.1.68. So 10.1.68 is the network which is hosted on server 2, and this is being routed on the Flannel network. And Flannel will do the VXLAN encoding. And Flannel will do the VXLAN encapsulation and send this traffic to the server number 2. Let's see if I can ping that from here, from the host itself. If I try to ping this container, which is running in the server 2, it's a 10.1.68.2, still I'm able to reach there. Because my machine, the server 1, knows that, oh, for reaching here, I have to send this traffic to the Flannel, and Flannel will do this transcoding, and Flannel will do the encapsulation and send this traffic to the server 2. And server 2 has a route back to the server 1, and that's how the whole thing will work. So here, when I try to ping to this container running on the server 2, when I send these packets, the routing table of this machine sends this traffic, which is in this network 10.1.68. It routes it over the Flannel, and Flannel will encapsulate this traffic and sends it to the server 2. Server 2 will receive this traffic and send this traffic to the container. Now, when the container needs to reply, the reply is towards the IP address of this machine, which is 192.168.251. something. And when this traffic comes to the server 2, so this machine, the container will just send this traffic to the default gateway, And default gateway, which is running on our virtual interface and this virtual switch in the server too, it knows that for routing towards the 192.168.251 network, it just needs to send it directly on that interface. So the return traffic doesn't come through the flannel, it just comes directly. Let's have a look if there is any networking namespaces. And yeah, we don't have. So Kubernetes does not create any network namespaces. We don't have anything here. So it just the CNI interface, the virtual bridge, and the flannel. That's how the whole thing works. So we have lots of encapsulation between the containers. We have lots of encapsulation between the hosts. So with all of this stuff, Kubernetes makes it very easy for placing the containers in different hosts and having them all to serve for one single purpose. And this is how the Kubernetes networking works. So as you can see, the underlying networking technologies that are used in the Kubernetes, they are all based on the open source technologies that we have already studied, like the Linux bridges and encapsulation, VXLAN encapsulation, layer 2 over layer 3. If you need to learn more about the Kubernetes, I suggest to have a look at the Minikube. Minikube is a tool by Kubernetes, and you can just run Minikube on your local machine and get familiar with how Kubernetes works. And you can also do some deployment of different services and applications using the Minikube. There are other tutorials also which you can find out inside the Kubernetes documentation, which can help you to understand, to get more hands-on experience using the kubectl and understanding of the services as well. The Minikube also does not support load balancing. If you need to have exposed load balancer in front of the pods, you need to either use some public clouds, or you can use the Metal LB and do some coding for doing the internal routing for the container networks. So this was about our Kubernetes networking lab. If you have any question, please feel free to ask me or write it in the forum. Thank you very much.